geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. Consider the acceleration, velocity and displacement of a tennis ball as it falls to the ground and bounces back. Direction of which of these change in the process? Option A, velocity only. B, displacement and velocity. Option C, acceleration, velocity and displacement. Option D, displacement and acceleration. Dear friends, remember, once the tennis ball is hitting the ground, it is bouncing back. By the time the tennis ball is bouncing, the direction of displacement and velocity are changing. Therefore, option B is absolutely correct. Okay. If you look at the bouncing of the tennis ball, look at the look at the arrangement, like how the ball is bouncing like this. After hitting the ground, it is keeping on bouncing. Finally, it comes to rest with the ground. Okay. Then look at the important point. When a tennis ball falls on the ground, it bounces back. Its velocity and displacement changes in the reverse direction. That point I told you. But direction of acceleration remains same. Direction of acceleration cannot be changed. That's why we opted B. Okay. Similarly, look at the another important problem. Very important problem. Asking like this. An aeroplane is flying in a horizontal direction with a velocity u. Velocity of the aeroplane given u at a height of 2000 meters from the ground. When it is vertically below a point A on the ground, a food packet is released from it. The packet strikes the ground at point B such that AB equal 3 kilometers and G is asked to take 10 meter per second square. Then the value of U. That means what is the speed of the aeroplane. Okay. Different options are available. Okay. For that, look at the aeroplane first. The aeroplane is moving in this particular direction. Look at the direction of the aeroplane. This is the direction of the aeroplane. He is moving with a velocity u. That speed is how much? But the person who is sitting in the aeroplane, when he looks the ground, he found a point A on the ground vertically downwards. And he has thrown a food packet. The food packet is thrown, right? He has thrown a food packet. The food packet is reaching the ground somewhere at B such that the distance AB is given, right? 3 kilometers. The distance AB means range only. Range equal to 3 kilometers. So range R equal to 3 kilometers means 3000 meters. And it is given that the vertical height, this is the vertical height, that vertical height of the flight H equal to 2000 meters. Asked to take G equal to acceleration due to gravity, G equal to 10 meter per second square. Is asking at what speed the flight is flying or aeroplane is flying. For that, as we all know, the range R equal to U into root over 2h by g. 2h by g. Range is 3000 meters is equal to u. You're asked to decide root over 2 into 2000 by g. G equal to 10. You're asked to take g equal to 10 meter per second square. 10. 3000 is equal to u into root over. It is 4000 by 10. 4000 by 10 is 400. 400. It is equal to 3000 equal to u into 400. Root over 400 is 20 square. 20 square. So this no this root 2 cancelled. Finally, it is 3000 is equal to u into 20. From this, the speed of the flight equal to 3000. 3000 divided by 20. This 0 cancel 150. 150 meter per second. Okay. If it is given, if the options are available in kilometer per second, then write u equal to 150 into 18, 5 by 18, right? For 150, correct? 150 divided by uh, 18 by 5, 18 by 5. It is 530 times. It is equal to, right? 540, 5400, right? 18 3 ja 540, 540 kilometer per hour. 540 kilometer per hour. Kilometer per hour. That is the answer if the options are available in kilowatt. Look at the options. Look at the options. Right? 540 kilometer per hour. Option B is absolutely correct. Understood clearly? Yes. Similarly, let's take the another important problem. Okay. Look at the screen. It is asking like this. A body is thrown vertical upwards from A, that the point A, the top of the tower reaches the ground in time t1. That means when a body is thrown from the top of the tower at a point A, vertical upwards, it reaches the ground in the time t1. Okay? If it is thrown vertically downwards from the same point A with the same speed u, it reaches the ground in time t2. If the same body is thrown vertically downwards from the same point with the same speed, it is reaching to ground in the time t2. Okay? If it is allowed to fall freely from the same point A, then time it takes to reach the ground is given by what is the time which is required to reach the ground when the same body is just dropping down from the same point at the top of the tower. Okay. For that, let me write it clearly. When when body thrown upwards, vertical upwards with a speed u, it is reaching to ground in time t1. Okay. When the same body is thrown vertically downwards, downwards with the same speed u, it is demanding the time t2. Okay. But body when body drop down, just drop down means initial velocity u equal to 0. Then the time required may be t. Then what is the time t in terms of T1 and T2? That is what he is asking. Look at the options. All options are given in terms of T1 and T2. Okay. For that, let us take the tower. Look at the tower. This is our tower. Let me mark the height of the tower first. Let me mark the height of the tower. So this is the height of the tower, H. Okay. And let me mark the ground. This is the ground. Listen careful. I am trying to explain each and every point. And let us mark the point A from which the body is thrown vertical upwards or vertical downwards or just dropping down. First, let us take the case 1. Case 1 is when case 1 is when body thrown upwards, vertically upwards with a speed u. Then it is like this. With a speed u, the body is moving vertical upwards up to certain height. Then in the return journey, it is reaching to projecting point. Finally, it will be reaching to the ground level. For reaching the ground, it is clearly given that the time required is t1. It is projecting vertically upwards with a speed u. Okay. Then, here the body is projecting vertically upwards, right? It is exactly opposite to the body falling to the ground level. Okay. Next, second case. Second case. Look at the second case. Second case is the point. From this point, the body is projecting down, vertically thrown down, not projecting, thrown down with the initial velocity u. For this, it is clearly given the time required is t2. Time required is t2. Okay. The last case, that is body is just dropping down. Case 3. Case 3. Body just dropping down. Dropping down. Okay. Dropping down means initial velocity u equal to 0. Then the body is moving towards the ground like this. The time required to reach the time required to reach the time required to reach the ground is t. Okay. As you know, the height of the tower is what h. Okay. For the second case, case 2, I did not write. Case 2, body, when body thrown, right, vertically downwards. Vertically downwards with the same speed. With the same speed means u. Okay. Now, here for reaching the ground, here the body needs to travel only the height h. Then one of the equations of motion is minus h equal to ut2 minus half into g t2 square. This is one of the equations of motion. But the body has to travel. For the first case, the body has to travel first this distance. Then, after reaching to the projecting point, it is traveling to a height of h. First, let me estimate the time which is required for projecting the topmost point and reaching to this point. Let that time is t. That time t to reach when it is projected vertical upwards to the projecting point t equal, remember, 2u by g. 2u by g. Right? Now, here the time required t1 equal to, right, this time required, this time required is, this time required for the second case is t2, t2 plus that t2 plus that t1 equal to t2 plus what t equal what, 2u by g. Actually, here the velocity should be taken negative because the body is projecting opposite to direction of body moving towards the ground. That's why it must be with the negative sign. Then it can be written as t1 minus t2 is equal to minus 2u by g, or minus t1 minus t2 into g by 2 equal to u. That is the u. So anyhow you got it, minus g by 2 into t1 minus t2. That is the u value. Now let us substitute this u value in the second case. Right? Minus h equal to, right, minus h, let us write minus h equal to, right, minus h equal to, otherwise let us write this equation above because I need some space, more space. Here minus H equal to U T2 UT2 minus half G T2 square minus H equal to, look at the U value. U value we got is minus G by 2 into T1 minus T2 minus G by 2 into T1 minus T2 into T2 minus half into GT2 square. GT2 square. Let us simplify this. Minus H equal to minus G T1 T2 by 2 plus minus into minus plus G by 2 into T2 square minus G by 2 into T2 square. Here G by 2 T2 square minus G by 2 T2 square cancelled. Finally it is, right, minus H equal to minus G T1 T2 divided by 2. This negative sign is cancelled. Finally it is H equal to G by 2 into T1 T2. Okay, T1 T2. So that is the H value. Now let us take the third case. Third case, here minus H equal to, here also ut minus half into g t square. Here the time required is t. But initial velocity, here the body is just dropping down. Initial velocity 0. Minus H equal to minus half into g t square. This negative sign is cancelled. Negative sign is cancelled. Finally it is H equal to g by 2 t square. Whereas for the second case, what we got? G by 2 t1 t2. Right? You got H equal to g by 2 t1 t2. Let the equation 1, equation 2. Compare 1 and 2 from equations 1 and 2. From equations 1 and 2, I can write that LHS are equal. Na? Since LHS are equal, you can equate the RHS. Then it is g by 2 t square equal to g by 2 t1 t2. This g by 2 part is cancelled. Finally t square equal to t1 t2 or t equal to root over t1 t2. That is the time required for just dropping down in terms of t1 and t2. Look at the options. Look at the options. Right? T equal to root t1 t2. Option C is absolutely correct. Understood clearly? I try to explain the each and every point. It is most expected problem as a repeating problem. I can say this is the 5-star problem. Okay? Yes.
Geobyte.